Hello, everyone. This video is to go over some of the exercises that are in Chapter 7. I'm just going to go through a few of them so that you kind of get a better idea of how to go about doing them for yourself and for practice for the quiz and for eventually these. Some of these will show up on the exam or some of these something similar. All right, so again, it's Chapter 7 that we have been that we read the baronet logic, propositional logic for this week, and each section has exercises that you can do to sort of make sure that you understand what's going on. Some of the exercises have their answers already in the back of the book, and I've posted those answers to the Canvas page. So these are different exercises, and I just want to go through them to sort of show you what's going on and how to do them. So let's start. So this is 7A number 1, part 1. So I'm just going to go through each of these. So basically what we're supposed to do in the first section here is just symbolize these different statements. And so what you're going to do, or what you should do here, is sort of see, okay, so the statement is you pass the exam only if you got at least a C. Now take that statement. Is it a logically complex statement? Yes. Why? Because of the phrase only if. The phrase only if we know is symbolized as, or we symbolize it as the sort of arrow. And now the way that you deal with these symbols, right, is you put sentence letters on either side of them. And so you need to figure out which sentences, we're going to go for which sentence letters. Well, it looks like there's 2 sentences here, right? You passed the exam and you got at least a C. So now we can sort of, just take these, right? You passed the exam, we will symbolize as P, and you got at least a C, we can symbolize as C, right? And so now what are we going to do? How is this sentence going to be symbolized? Well, the only if, right, is right there in the middle. So it's going to be P only if C. And that's how that one works. All right, on to number 20. 20, also similarly, right? So it is not true that Titanic is the highest grossing film of all time. Is this a logically complex statement? Answer, yes. In what way is it logically complex? Where's the logical word in this phrase? Right here, right? The word not. And it is not true that, right? Basically, this whole phrase is just a version of negation, right? Where we've got the tilde. And now, are there any other logical symbols in this statement? It's not true that Titanic is the highest grossing film of all time. And you go through it, right? Negation, conjunction, disjunction, conditional. Nope, just negation, right? So then we can take the sentence and try and turn it into a sentence letter. What's the sentence? That Titanic is the highest grossing film of all time. Okay, cool. So that's one large, simple sentence, right? It's Titanic being the highest grossing film of all time. So this is the predicate, the property here, and Titanic is the subject. So we can just call that, T. So we'll just say that this sentence, right, we're going to call it T. And now we can say, okay, T, not T. Not T is the statement, and this basically just says it's not the case that Titanic is the highest grossing film of all time. Done. All right, how about this sentence? Cats and dogs make great pets. Well, is this sentence logically complex? Yes, because of the word and here. But there's not 2 sentences on either side of this yet, right? The word cats is not a sentence. So what do we need to do? Well, we need to translate this into something that has 2 sentences, right? So what should we do with that? Well, we should think of it this way, right? This sentence can be sort of, it says the same thing as this sentence. Cats make great pets, and dogs make great pets, right? And now this sentence is easily to sort of see how we should translate it. We've got and there, so we know that we're going to use the ampersand. But then we've got 2 sentences on either side, right? this one, which we can call C. Cats make great pets. And this one, which we can call D, right? Dogs make great pets. Great. Now we've got these all translated. We've got letter C and letter D. And which one comes first? It says C, C, and D here. And there we go. Now it's translated. All right, last one here. Today is Monday unless it's Tuesday. Well, obviously, right? No, not really. Today is not either of those days for me. Today is Friday. So what exactly is going on here? Well, is this a logically complex sentence? It is. You have to go back and think a little bit harder. What is the logical term here? It's the word unless. And I discussed this shortly in lecture, but the word unless actually means the same thing as or. And you can kind of think about this. It's a little bit tricky, but think about it this way. Unless, just swap the word or here, right? Today is Monday or today is Tuesday. Yeah, today is Monday unless today is Tuesday. Well, yeah, right? Like if today is Monday, then it's Monday, right? Unless today's Tuesday, right? It could be Tuesday. And similarly, today is Monday or today is Tuesday, right? It's one or the other. Basically, that's all of this is saying. So if we're using or, then disjunction, right? We've got the symbol V here. And now it's pretty easy. We just need to swap out our two sentences, right? So today is Monday is our first one. And we can do that with M, right? And today is Tuesday with T. You can choose sort of any sentence letter that you want. I use these letters because I just sort of picked them at random, but because they make sense, right? So Monday for M and Tuesday for T, right? Up here, we've got C for cats, D for dogs. It doesn't matter what letter you use as long as it's consistent. And as long as you don't sort of use the same letter for different sentences, right? Because then that would just be confusing. So how do we symbolize this? Again, today is Monday unless today is Tuesday. So it's just going to be M or T. All right, that's pretty straightforward. Hopefully that helps you understand how you can symbolize these sentences. Moving on to 7a.2, we can try and determine whether or not there are sufficient conditions and necessary conditions in these conditional statements. This is relevant to some of the stuff I went into detail over when discussing the material conditional. So is there a sufficient condition in number 7 here? If I live in the White House, then I am the president of the United States. Okay, well, we know that living in the White House and being president are related in some way, right? The president of the United States lives in the White House. That's like supposed to be a thing, right? But remember, sufficient condition. When we're asking about sufficient conditions, we're trying to see whether or not there's a relationship between the first thing and the second thing, where the first thing guarantees that the second thing is true. Guarantees, right? And think about it, right? So does living in the White House guarantee that you're president of the United States? Well, it's a pretty good reason for thinking you're president of the United States, right? If you live in the White House. But are there any other people that live in the White House? Well, yeah, sure, right? The president's kids, maybe, the president's staff, the president's wife, the first lady. So does living in the White House guarantee that you're president of the United States? No, right? It doesn't guarantee it. It doesn't guarantee it because it's possible to live in the White House and not be president of the United States. You could be the first lady. All right, so that's a no. Let's take this other statement. If I am over 21 years of age, then I am over 10 years of age. Okay, well, so being over 21 requires being over 10. So does it guarantee it? If you're over 21, are you guaranteed to be over 10? Well, yeah, right? It's impossible to not be over 10 if you're over 21, right? It's guaranteed. Great. So this one, yes, it is a sufficient condition. Hopefully that helps go through some of the other ones to sort of get that into your head. Like, does the first condition guarantee the second condition, right? Make it so that it has to be true. And if it's thumbs up, sufficient condition. Thumbs down, not sufficient condition. All right, let's move on to necessary conditions. Remember, necessary conditions are different than sufficient conditions. A sufficient condition is a guarantee. A necessary condition is just a must. like it must be this way for this other thing to happen, but there can be lots of necessary conditions that aren't sufficient. So let's take this one. If there's not oxygen in the room, then there is not a fire in the room. All right, so, well, oxygen is necessary for fire, right? But what else is necessary for fire? Fuel, like an ignition, right? So here's the question. Is no oxygen in the room necessary for there to not be a fire in the room? Well, not really, right? Why not? Well, no oxygen in the room is sufficient, right? It guarantees that there's not going to be a fire in the room. But is no oxygen in the room something that has to be the case for there to not be a fire in the room? No, there could be lots of things that aren't the case for there to not be a fire in the room, right? It could be that there's no fuel in the room. It could be, right, the whole room is made of concrete or something. It could be that the whole room is filled with water, right? Those are all reasons that could make it the case that there's not a fire in the room, right? So this isn't a necessary condition on there not being a fire in the room, but it's a sufficient one. All right, what about this one? If I am not eating a banana, then I am not eating a fruit. Is this necessary? Is it necessary that you not eat bananas in order to not eat fruit? Well, again, no, right? Just because you're not eating a banana doesn't mean you're not eating fruit, right? If you could be not eating an apple and thereby not eating fruit. So it's not like you have to not eat a banana in order to not eat fruit. But you could think of it this way, right? In order to not eat fruit, you must not be eating a banana, right? So if we flip this around, then it is going to be true that there's that is a necessary statement, right? So this way, it's not a necessary statement. But if we flip it around and think about it in the other way, if you're not, in order to not eat fruit, right? If I am not eating fruit, then I must not be eating a banana. That would be a necessary statement. All right, moving on. Now we're looking at well-formed formulas, and this has to do with the way that we translate things. So once we translate statements, we want to make sure that the statements are correct in a sense. So do we have all the symbols in the right places? So let's look at number 6 here. So what does this say given our logical language that we've kind of been using so far? It says L, and then we've got the arrow, which says only if, and then we've got the negation, and then we've got parentheses, and then we've got P, and then we've got wedge for or, and then we've got arrow, and then Q, and then parentheses. All right, so is this a well-formed formula? Are all of the symbols in the right order, or is there a symbol that is, mistaken? Well, hopefully you're seeing that there is a symbol that's mistaken. So you might think first off, this is a problem, right? The arrow and then the negation, but that's actually okay because the negation attaches to sentence letters. And this basically, whenever you use parentheses, you've kind of created one large sentence. So it's okay if the negation is in front of a parentheses, even if it's after a logical symbol like this. But what's not okay is these two next to each other. And why is that? Well, the reason is because each of these symbols requires having 2 sentence letters next to it, right? If there was another sentence letter in between here, that would maybe be okay, but then we would also need more parentheses. But as it stands, this sentence says P or only if Q, and that doesn't make any sense, right? You can't do that. You can't say like Felix is a cat or only if Joey is a dog. What? That doesn't make any sense. So this is bad, not a well-formed formula. What about 11? Is this a well-formed formula? This says P and or Q. Also bad, right? Here I just wanted to sort of point out some of the bad ones. Determining whether or not something is a well-formed formula is relatively easy. But if you are confused, definitely shoot me an email or come to office hours. All right, 7b.2. Here we're trying to pick out what the main operators are of different statements. So this should hopefully be relatively straightforward if you paid enough attention. But if you're still having trouble with this, again, office hours, very helpful. So this is number 8. It says P, or if Q, then R, parentheses, and oops, let me change that to our actual symbol. And it's not the case that R or S. Great. So this whole statement is complicated. And there's 1, 2, 3, 4, 5 different symbols that could be the main operator. Which one do you think the main operator is? Well, if you remember, what we should do, we should always think of, think of it like math. Do the things that are inside the parentheses first. So here, we've got some parentheses and brackets. Brackets, basically, you can always use brackets and parentheses kind of interchangeably so that you can kind of keep track of which ones are where. But the idea here is just look, okay, so we need to do this first, and then this and then this, and then this inside here in order to determine the truth value of the whole statement. But the last thing that we need to do is determine the and that's basically going to make this the main operator of the whole statement, because in the end, what we're going to try and figure out in order to determine the truth value of this whole statement, we're going to have to figure out whether or not this part's true and whether or not this part's true, right? The second part, and only under cases in which both of those are true, right? Because of the and, is the whole statement going to be true. So that makes and the main operator. What about this statement, right? 11, we've got not Q or P, only if R. Well, here, hopefully it's also kind of obvious, right? Inside the parentheses, all of this stuff is, so this is going to get kind of, we're going to calculate it first, but it's the last thing that we calculate that tells us what the main operator is. So the main operator here is only if. All right, on to 7b.3. All right, so now here we're asked to just translate these sentences straight up, right? Because they're logically complex statements. Here, I'm not going to be using, I'm not going to put letters. I'm going to use letters, but I'm just going to say them. I'm not going to copy and paste. It's totally unnecessary. Right. So here, let's just come up with something, right? Not both Mike and Jane wear braces on their teeth. Well, what we need to do here is, first of all, change this statement into two statements, right? Mike and Jane wear braces on their teeth. Well, what does that mean? That means Mike wears braces and Jane wears braces. So let's use the letters M and J. And then we've got the word and here, right? So we know we're going to go start with M, and we're going to use this, and we're going to go with J. But now we need to see, okay, this is a more complicated statement. It says not both Mike and Jane wear braces on their teeth. Well, okay, so this statement M and J is basically the same as both Mike and Jane wear braces on their teeth. So not both. Well, does that mean that we should just put the negation out here? Just like that? No. Why? Well, because this says Mike doesn't wear braces, right? It says it's not the case that Mike wears braces and Jane wears braces. So what we need to do is put the parentheses around the whole thing, because now this says that it's not the case that both Mike and Jane wear braces, right? Hopefully that is clear. All right, what about this one? If we are not careful and we don't change the oil often enough, then the engine will be ruined. All right, so let's get some letters here. I'm going to start off, I'll just put them in here, right? So it's we'll call this one C, so we need to be careful. Whoops. And then so here's an and, right? So we can just change that to this, and we don't change the oil often enough. Okay, so let's call this O for oil. And then we've got then. Okay, so nice. We've got the arrow. The engine will be ruined. Okay, cool. Let's just call this E. Oh, funny. Changing things to symbols. All right, cool. So now we've kind of already quasi interpreted all of this, right? The if then part, we've got that. We've got the and. Okay, now what else do we need? Well, we need to figure out the sort of order. So we've got C and and O, and then arrow, and then E. Well, okay, so this statement is like close, but it's not done yet because we need an order of operations. We don't know here, right? If this was like a math statement, okay, imagine it was 7, oh my gosh, 7 plus 5 minus 6. Which one do you do first, right? Which one are you supposed to do first? You don't know, right? There's sort of normal order of operations, but that doesn't tell us here. So what we need to do is figure out where the parentheses go. And then the question is like, okay, well, what's the statement say? It says, if we are not careful and we don't change the oil often enough, then the engine will be ruined. It's not the case that we're saying like, if we're not careful and if we don't change the oil often enough, then the engine will be ruined. No. The if comes out here, out in front. So it's ultimately trying to tell you that these two statements need to kind of be pinned in together. And then now we know, so this is the main operator, and this whole statement is an if-then statement. It's a conditional. All right, next. She is athletic and creative, unless I am mistaken. Ooh, this is a good one and tricky. So first of all, let's see. Okay, we've got an and here. She is athletic and creative. Okay, so she is athletic and she is creative. So let's use that as like A for athletic. And okay, and there's an and we'll use C for creative. Great. And then it's like, unless I am mistaken. Oh, well, what does unless mean? Unless means disjunction again, right? So it's like either she is athletic and creative or I am mistaken. Yeah. So we've got a disjunction there, and we'll call being mistaken M. Okay, well, now we're stuck again. We've got these three things. Which ones are going to get kind of grouped together? Well, it's supposed to be both, right? It's supposed to be both these. It's like either she's athletic and creative, or I'm mistaken, right? And you can kind of tell sometimes with this comma, right, where the main operator is going to go, because that's like the main point of the sentence. So the main operator is here, the or. So that's going to be the last thing that we want to compute for the truth value of the sentence. So that means we're going to need to do A and C first, and so we need to put those in parentheses. All right, on to 7C part 2. Here we're finally getting into some truth table-y type stuff. So this one, it says to let P be true, Q be F, R be true, and S be F, and then determine the truth value of the whole statement. Okay, well, that seems sort of straightforward enough. So here, let's just kind of work our way through these things. So we know that Q is false, right? And we know that R is true, and we know that S is false. Okay, now what exactly are we doing here, right? So this is Q is false, R is true, S is false. Well, how do we determine these things? Oh, okay, well, so we need to use the truth tables that we have access to, right? And our truth tables tell us what the truth function is for each of the symbols that we've been discussing. So what's the truth function for the wedge, for or? The truth function for the wedge is that the sentence is true just in case one of the conjuncts is true. So just one side has to be true for the whole thing to be true. So that means because R is true here, that means that this whole sentence, Q or R, is going to be true. Great. And this is now the more important truth value, right? So I can sort of make it bold because it now tells us what's important for the whole sentence, Q or R. And now this whole sentence, the truth value for the whole sentence, is what we're going to use to determine the truth value of this symbol, which should be there you go, should be the conjunction symbol. And so now we got to figure out, okay, so is this whole statement true, right? It says Q or R, which is true, and S, which is false. Well, we know the truth function for the conjunction symbol for and is that both sentences, both sides need to be true for the conjunction to be true. So because S here is false, we now know that the whole sentence is false, right? The whole sentence is false, so this sentence is false. I mean, it's not like it's a bad thing. It's just that's what it is. It's false, and so that's the answer to that question. All right, what about this one? Not P, not if not P, then If not S, then not R. That's what this sentence says. Confusing, but great. All right, so let's say P is true. Right, let's do that. P is true. And S is false. And R is true. Great. Okay. Now we can convert these, right? Because we've got these negation signs. We know that the negation sign basically just flips each of the things. So in front of this, so right, actually this is going to be false now, because not P is, if P is true, then not P is false. And what about this one? Okay, well, F, not false is true. So, right, so now we know that the negation here is true. And then what about R? If R is true and we've got a negation sign, well, then we know F, right? Not R is going to be true, or not R is going to be false. All right, great. Now, now we've got these, we can start trying to figure out what should go underneath these conditional symbols, the arrow. And which one should we do first? Well, we can't do this one until we've done this one, because we have to work on the inside of the parentheses before we do anything. So first, it's good to figure out the negations. Now we need to figure out what this one is. And this one applies to basically both of the negated symbols, right? So we're going to take the T here and the F here seriously. And what's the truth function for the conditional, for the arrow? Well, if you remember, the only time that so basically the truth function for the arrow is the conditional statement is true just in case the antecedent, the first part, is false, or the consequent, the second part, is true. That means that the only time where a conditional statement is false is when the first part, the antecedent, is true, and the second part, the consequent, is false. Well, that's exactly what we have here, right? True antecedent, false consequent. So that means that the whole conditional is false. Make that bold because that's the important one. Now we've got this whole thing, right? We've got this whole thing figured out. It's false. Well, okay, so now we've got false up here, right? And false in here. And this is another conditional. So what were the rules for the conditional again? Well, okay, so the rules for the conditional, the truth function states that a conditional is true just in case the antecedent is false or the consequent is true. Okay, well, wait, so here the antecedent is false. So perfect. It's true. The whole statement is true. Great. And we're done. That's the whole thing. That's how you do this section in 7C.2, using these truth values to try and calculate the more complicated truth values. All right, on to 7D. Now we're doing some real truth tables, and then we'll sort of go through these and then be done. All right, so real truth table. First, it says create a truth table for this statement. So I've already created the truth table here. The way that you do that, and I'll do that in a minute for you, is just like insert table, and then you just make a table, and you got to figure out how long you want the table, right? So here I just sort of know, because I've got 3 sentence letters, that I'm going to need 8 lines. So I've got 8 lines here. So there's actually a 9-line truth table because I want this first line. And then I need 4 rows. Sorry, 9 rows, 4 columns. The columns here because I want this last column for the entire thing. And so now I can just go through and put in my letters, right? So I know it's going to be half T's on the one side and then half F's on this side. And then the next one down, I'm going to do 2 T's, oops, and then 2 F's, and 2 T's, and 2 F's. And then for R, I'm going to do TF, 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 TF. Now, why did I do that? That basically makes it the case that we have now every possible pairing or every possible combination of truths and falses for P, S, and R in each of these, right? So we have the situation where all 3 are true. We have the situation where 2 are true and 1's false. We have the situation where all 3 are false, right? All the situations possible. That's basically just what we went through here. And now we can translate all of this over to here to determine what the truth value is on this sentence. So first, I'm actually just going to figure out this intermediate part so that it's going to be easier for us to kind of figure out the whole thing. So what's going on here? We've got not S or not R. Well, or here works just in case one of these two is true. Well, here we got S is true and R is true, but not S means false and not R is false. So that's going to be false for the disjunction here. And then using that, now that I know that this is false and I know that P here is true, well, that means that this is false, right, over here. And now, so false, false, that makes this whole thing false. So now I know that the whole thing is false and that I'm done with this one. All right, moving down. So now I've got R is false here. So that makes this whole thing, so this part right here is going to be true. And that's going to make this whole disjunction true, right? So I know now that this whole disjunction is true. And now that I know that this whole disjunction is true, I don't even have to pay attention to what's going on here with P anymore, right? Because this disjunction, all I need to know to make that disjunction true is that one of the disjuncts is true. Great. So I already know that, right? Because this whole side now is true. So now I know one of the disjuncts is true. Great. True. Cool. Third row. True, false, true. Okay. So now I've got S is false. Well, now I know that S is false. That means not S is true. So that means that this whole disjunction again is going to be true. Cool. And once I know that, then again, it doesn't even matter what P is. Cool, true, right there. All right, next one, true, false, false. Well, oh, look, now S and R are both false. So that makes both of these come out true, right? Not S is true and not R is true. So that means that this whole side is going to be, once again, true. And then that makes my job so much easier, right? So the whole thing is true. Oh my gosh, and it's going to get even easier for us now. Why? Because the rest of this truth table on the left, P is false. If P is false here, 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 and here, then that means that not P is going to be true. And if not P is true, then this disjunction, right, is going to be true all the way through. So I can literally, now I know that all these are going to be true, and I don't even have to do all the work calculating the rest of them. And that makes it so much easier. If you didn't follow how all of that worked for me in my brain, come to office hours and we'll talk about it, because it's really simple kind of once you get it. It's just like figuring out how to calculate everything and then getting it. That's the hard part. And there's lots of other ways for me to explain these things. It's just I'm going through this to a Zoom screen. So am I doing it well? Maybe not for you, right? Maybe your brain works differently. All right, let's try this one. Okay, so this one is if Q, then R and R. Whoops, let's change that symbol. Remember, the dot and the ampersand basically mean the same thing in lots of cases. Change that here too. All right, so what's going on? Well, first, let's just write up our truth table. True, true, false, false, and R is true, false, true, false. Why do I only need 4 lines here, 4 rows? Well, because I've only got 2 sentence letters, right? 2 sentence letters. And if you remember, the trick is 2 to the n, where n is the number of sentence letters. So 2 to that many times. So here, 2 to 2. 2 to the second power is just 4, right? 2 to the third power, right, up in here is 8. 2 to the fourth power is 16. It gets way out of hand, right? 2 to the fifth power is 32. There's too many rows, right? We don't want to do that. So I'm just going to stick with, at the most, right, for you guys, I'm going to stick with 3 because otherwise it just gets too complicated. All right, so now we've got all the truth possibilities, right? We've got the case where Q is true and R is true, where Q is true and R is false, where Q is false and R is true, and where both are false. All right, so now let's figure out the truth value over here. Well, first we got to work inside the parentheses to figure this out. If Q then R, what are the situations in which if Q then R is true? Remember, the conditional. The conditional says a conditional is true just in case the antecedent is false, the first part is false, or the consequent is true, the second part is true. The only case in which that doesn't happen is the case in which the antecedent is true and the consequent is false. The first part's true and the second part's false. So we can kind of look there and say like, oh, okay, QR. Well, look, this one's true, true. Okay, true. Oh, this is the true, false one, right? True, false. Okay, so that one's going to be false. This next one is false, true. So that's going to be true. Why? Because remember, the rule for the conditional says that if the antecedent is false, the conditional is true, or if the consequent is true, the conditional is true. Well, that happens to be both in this case. And then the third and the final one, right, the antecedent is false. So once again, the conditional is true. Okay, now we've got this worked out. Well, now we just have to compare that with R, right? Because we've got and here. So true, and in this case, R is true. So true. Whoops. In this next case, we've got false, oh, and another false. So we've got false. Third case, we've got R being true. So we've got true again. And finally, down here, we've got false, R being false. So true and false on the other side, that makes this false. So it's the way that the conjunction works, right? For conjunction to be true, both of the conjuncts have to be true. Both sides have to be true. Okay, so that's how that worked. All right, now we're moving on to validity or invalidity for arguments. And this is kind of the most complicated case. So hopefully you've made it this far. Just 1 second. All right, so how are we going to deal with this? Well, I left this blank so that I could show you how to build a table. All right, so what's going on here? Well, basically what we've been given is 2 premises and a conclusion. And remember, the way that we're going to figure this out using truth tables is we're going to make a big truth table. We're going to put the premises in and the conclusion in, and we're going to see if there are any situations in which the premises are true and the conclusion is false. If that ever happens, then that means that the argument is not valid, right? And the argument's not valid in that case because the premises could be true while the conclusion could be false. All right, so how are we going to do that? We're going to make a table. How many rows and columns do we need in this table? Well, we've only got 2 sentence letters, S and R, but we have 2 premises and a conclusion. So that means we need S, R, the first premise, the second premise, and the conclusion. That's going to be 5 columns. And then how many rows do we need? Well, because we've only got 2 sentence letters, we're only really going to need 4 rows. We'll add a 5th one just so that we can input everything, right? So what's going to go on here? Right, we need 5 across and 5 down. If it needs to be bigger, you can just click the word insert table. And then from there, you can sort of put the numbers that you need in, right? All right, so now with our table in hand, we can sort of start with this. We want R, we want S, we want our first premise. And we want our second premise, which is just S, and we want our conclusion, which is just R. So actually, you know, this thing's actually going to be kind of easy because we're just going to be able to translate stuff over from R and S. Great. So basically, true, true, false, false. All right. And S is true, false, true, false. Let me move this so that it doesn't bother me so much. There we go. All right. Now what? Well, okay, we can actually literally just transfer these over to here where we're trying to figure these things out, right? So this is a premise, and so that's really simple. So this is just be true, false, true, and then false, and R is going to be the same over here, right? So we're going to be true, true, false, false. Are we done? No, not yet. Why? Because we need to now know. So now we know this is the conclusion, R, but we need to figure out if there are any situations in which the conclusion is false, where both of the conditionals or both of the premises are true. And these are the 2 premises, right? So really, in a way, if you're smart, all you need to worry about is this line right here. But I'm going to fill it in all the way through, just so that we can kind of have completeness. All right. So what's going on here? Well, we need to determine the truth value of this premise. So how do we do that? Well, look. Okay, there's a disjunction here of two negated symbols, and then the whole thing is negated. So what we're going to have to do is we're going to have to figure out the truth value of this, and then just flip it. So not R or not S. Well, not R is going to be false. Not S is going to be false. So this whole thing is going to be false in here. But then the negation sign, so it's going to be true, right? Great. So now we know this whole thing is true. And in this situation, we've got, premise 1 is true, premise 2 is true, conclusion is true. Fine. That's totally okay for a valid argument. Okay, what about the second one? So we've got not R or not S. Not S here is going to be true. So we now know that this disjunction is going to be true over here because one of the disjuncts is true. And then with the negation sign, we're going to have to flip that. So false. So the whole thing is false. Okay. But in this line, right? So now premise 1 is false. Premise 2 is false. Conclusion is true. That actually doesn't matter in this case. Why? Because we're not looking for situations in which the conclusion is true and the premises are false. We're just looking for cases in which the premises are true and the conclusion is false. That's how you tell whether or not some argument is not valid. All right, next one, the third one. This is the one that's important. Okay, not R or not S. So S is true, so that's going to make this part false. And R is false, so that's going to make this part true. So that means that the disjunction in the end is true. And then the negation here, that's going to make this whole thing false. So now we know that this whole premise is false. Okay, and now we've got false premise 1, true premise 2, conclusion is false. Okay, that's fine, right? One of the premises is false. If one of the premises is false, then the conclusion is false. That doesn't tell us anything. It doesn't tell us that this is an invalid argument. All right, and then finally the last one, false, false, all the way across here. Well, is this going to be true, right? So the conclusion or the disjunction, not R is going to be true, not S is going to be true. So the disjunction is going to be true, right? And then the negation, so that's going to turn this out to be false. And once again, that doesn't matter for us, right? False premise, false conclusion. Fine. Guess what? We have now determined that this argument is not invalid, right? It's not invalid. Why? Because there are no situations in which the premises are true, right? The two premises of the argument are true, and the conclusion is false. There's a situation in which both are true and the conclusion is true, but there's no other situation in which all of the premises are true and the conclusion is false. So it's not invalid. So that means it's valid, right? It's a valid argument. Great. So now we know this argument is valid. All right. Let's move on to some more complicated ones. All right. So now we got P, Q, and R. P, Q, and R are all, so that's 3 sentence letters. So we've got P, Q, R, premise 1, premise 2, conclusion. That means we're going to have 6 columns. And because we have 3 sentence letters, that means that we're going to have 8 rows. Let's see, I'm going to do insert table. And that means I'm going to do 6 columns and I'm going to do 9 rows so that we can put the letters in up top. Okay, so that means we've got P, we've got Q, and we've got R. Then we've got if P, then Q. Then we've got if Q, then R. And then we've got if P, then R. And that's premise 1, premise 2, conclusion. All right, now let's just start calculating to sort of see what's going to happen here. So true, 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 right? First 4. False, 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 false. Second 4. Now on to Q. We got true, true, false, false, true, true, false, false. All right, now with R, we've got true, false, oops, true, false. All right, now we've got these taken care of. Now we can start figuring out what's going on here. Remember, conditional, true antecedent, false consequent, only situation in which the whole thing comes out false. So all you got to worry about is those situations. So we just got to look like, okay, it's going to be true. Otherwise, only in cases, it's going to be false only in cases where P is true and Q is false. So let's just look right here, right? Oh, okay. So there are two right there. It's going to be false here. It's going to be false here. But P is false all the way down here. So, okay. So at each other one, it's going to be true. We can just sort of see that from knowing how the truth condition works, knowing how the truth function works for the conditional. Now we can do the same thing for if Q then R. Okay, let's just compute it. We're looking for situations in which Q is true and R is false. Okay, so that's going to be right here on the second one, right? False. Q, okay, this is false here. Oh, and this one right here. Q is true and R is false. But none of the other ones are set up that way, right? So all the other situations, we know it's going to be true. Great. Okay, now last one. P is true. So now we're looking for situations in which P is true and R is false. Well, okay, so P true, 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 false. Okay, so there's one right there, right? The second one, false. Now true, 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 false. Oh, another one. And then false. Oh, and then P is false all the way down. So it's not going to happen the rest of the lines, right? And then these two are also going to be, oops, true. Okay, cool. Now we've got it all filled out. Now remember, what are we trying to do? We're trying to figure out if there are any lines where the premises of the argument are true and the conclusion is false. If there are any lines where the premises are true and the conclusion is false, we have an invalid argument. So let's look. Line 1, true, true, true. Okay, good, check. Line 2, true, false, false. Well, one of the premises is false, so it doesn't matter, right? This line doesn't matter. Here, false, true, true, premise is false, so it doesn't matter. Here, false, true, false, again, premise is false, doesn't matter. And okay, true, 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 that's fine, that's good. True, false, true, premise is false, so it doesn't matter. And then these last ones, oh, true, 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 and true, true, true. Great. There are no situations in which the premises themselves are true in the same line and the conclusion is false in that line. Good. It's a valid argument. This argument is valid. If you think about it, this is a classic argument that's called, oh, I'm blanking on the word now. Whoops. But yeah, when you go from if, like it's if P then Q and if Q then R. So if P then R basically just follows. All right, last one. Last one. If you've made it this far, good on you. Okay, so what's going on here? We've got two sentence letters, P and S. So that means we're only going to need 4 rows, which is great. How many lines are we going to need? Well, we've got 2 premises, this long premise and this short premise, and 3. So we need 5 columns, right? So let's do an insert table. We need 5 columns and we need 4 rows. I'm going to do 5 though, just so we can put things in at the top here. So we got P, we've got S, then we've got this long premise. And then the short premise, not P, and then not S as conclusion. All right, let's just start computing here, right? So true, true, false, false, true, false, true, false. Great, we got that taken care of. Now, what's easiest? Well, not P and not S are super easy, so let's just go ahead and compute those. Right, so this is going to be false, false, true, true. Not S is going to be false, true, false, true. Great. Now we've got the conclusion done and one of the premises done. Now we got to figure out this one. Okay, what should we do? How are we going to do this? So we've got not P or not S. So let's figure out these this one first, right? Because this is the sort of innermost one. So true, true. Well, not P is false, not S is false. So here we've got a false case. Okay, and then now P only if false, right? False sentence. Well, what's going on here? Well, we know that the way that the conditional works is if you have a true antecedent and a false consequent, then the whole thing comes out false. So true, false. Well, it's gonna be false. All right, now we know that one's false. Here again, both premises are false. Conclusion is false. Doesn't do anything. Doesn't tell us that this is an invalid argument. All right, what about the next one? True, false. Okay, so how does that work here? P is true, that makes it false here. S is false, that makes this true. Okay, cool. So that means the whole disjunction is going to be true. All right, now we've got true antecedent, true consequent. Great. Okay, so this whole thing turns out true just because of the way that the conditional works. Again, now here we've got this premise 1 is true, premise 2 is false, conclusion is true. Doesn't matter. Premise 2 is false. Doesn't tell us anything about the validity or invalidity of this argument. All right, what about 3? We got false, true here. So, okay, so because P is false, that means not P is true. So this disjunction is going to turn out true. And then what do we have? We have false, true. Okay, so that the antecedent of, is false here. And the way that the conditional works, if the antecedent is false, then the whole conditional is true. Okay. And now we've got true, true, false. Oh my gosh, look, there we found one. We finally found one. This, and basically you can stop right there, right? Once you found one, you're done. This is a situation in which both premises are true and the conclusion is false. Now, what does that mean? That means that this argument is not valid. It means that it's possible in some world, the world basically in which P is false and S is true, the situation in which P is false and S is true, no matter what the premises are, right? Like however you want to fill them in, no matter what the premises are, in the world in which P is false and S is true, we know that this premise, if P, then not P or not S, is true, and this premise, not P, is true, but the conclusion, not S, is false. So that means that this is not a valid argument. It's an invalid argument. All right, I hope that helped. If it didn't come to office hours, bother me more, and good luck on your quizzes and the eventual midterm and final.